The one who did. It was that person.
Wait, which one was that?
What who did what? The quote? The one who did the number 2?
No, the one who smeared it on the wall.
Oh.
Which one was that, though?
Well, I'm recording, so I'm not going to say anything.
Can you, like, throw in a random-ish, not so random, letter for a hint?
Later.
Thank you.
I thought that was the hint for a second. I was like, what?
Alpaca.
I don't understand. Also, isn't the first part supposed to have DT as well?
You asked the same question yesterday, and I said it doesn't matter.
Well, I forget things, okay?
Okay.
Oh, well.
Are we? Oh, wait, never mind. I forgot we're not in physics today.
And I'm adding the parentheses because it makes me happy.
Well, you do that.
You don't
We had
have
already
to.
integrated this, so I'm just going to rewrite it. The world was that?
I'm sorry, what did you just say?
I said, what in the world was that?
Oh.
What?
I heard world that had more of an H and a not as happy world to it. If you know what I mean.
No, I said, what in the world was that?
Yeah.
I'm bracketing these off because it's a little confusing.
Makes sense to me.
And this is giving us the total distance. So evaluated at 1 would be 2 minus 9 to negative 7 plus 12 is 5 minus 0 minus 16 minus 36 negative 20 plus 24 is 4 minus 5. So that would be 5 plus 1, which is 6. Fascinating. This one was also 6. I think the one yesterday was 6 also.
I was about to ask the same exact question I was about to ask earlier, but then I responded with, oh, I forgot we're not in calculus. And I was about to say it again.
We already got this though.
I mean, in physics. Oh my gosh.
We're almost there.
Almost. One more class.
I'll refill this very quickly.
I'm just going to go ahead and write the problem statement. I'll read the question in a second. I don't know if it's just me, but I always have to decide if particle is like P-A-R-T-I-C-L-E-S or if it's P-A-R-T-I-C-A-L-S.
Yes, it just feels like it should be A. I don't know why.
And then I always look in the book and it's L-E-S and it's just is what it is.
Wait, are you talking about particles versus particles?
Yeah.
So the official problem statement says a particle travels with velocity v of t equals t minus 2 times the sine of t meters per second for 0 less than or equal to t less than or equal to 4 seconds. And then part A, what is the particle's displacement? So to find the displacement, we would have to integrate from 0 to 4 of that function. Now, do you know how to integrate that?
We like split it up.
It's not being added.
Do we take
What if we distribute?
Huh?
What if we like distribute?
Or we could just use an INT. Let it do it for us.
True.
Instead of making our lives really, really difficult.
Well, that wasn't an option in our heads.
That's why I said, do you know how to do this? The answer was no. And then I was going to say, how about our calculator? And obviously, in your calculator, I would recommend you just use X. Also, radian mode. Because it'll be plugging into a trig function.
How many?
Two.
Negative 1.4.
Meters.
Matters.
So now part B wants to know the total distance traveled. Which we can find the zeros where it stopped, and then we can find the integral of those intervals and do all of that. Or we can just do the integral of the absolute value of v of t and then do an INT on that. And when you type that in, you're going to have to put those absolute value bars because otherwise you will get a different answer. Absolute value bars are under math. That's a nice review problem. Do you have the answer?
Yeah, maybe we do.
Takes me a
I
second
think your
to type.
iPad like off now or something.
Yeah.
Like you took so long that it just turned off.
It takes me a second to type it all. Okay.
Also, the Kool-Aid was good.
It would. I love them. I also have the little packets. If you need some, you know. But they only have them and they're only like $1. So
That's not bad.
yeah. I got 1.9 meters.
Meat matters.
So just for reference, we're not going to actually do it, but we could do the integral from 0 to 2, because basically if we took this equation and set it equal to 0, we would get a 0 at t equals 2, at t equals 0, and at t equals pi. And then we would break this into intervals, and so we would have the integral from 0 to 2 plus the integral from 2 to pi plus the integral from pi to 4. And we could do these each individually and get an absolute value of a number, which would be negative 1.09, 0.23, and 0.59. But for the sake of time, we're not going to do all of that. But you could also do it that way and then just add them together.
I don't like that sometimes the absolute value bars end up looking like ones.
I try to make them really big.
Yeah.
All right, this
Sometimes they just look a
next
little too small.
question, you might want your book open for.
Uh,
With that one.
It's an odd one.
like, oh.
But there's a table of numbers, that's why I said this. So it says filling milk cartons. A machine fills milk cartons with milk at an approximately constant rate, but backups along the assembly line cause some variation. The rates in cases per hour are recorded at hourly intervals during a 10-hour period from 8 a.m. to 6 p.m. Use the trapezoidal rule, that's why I said it was a good throwback problem, with n equals 10, which we had been previously doing n equals 4, to determine approximately how many cases of milk were filled by the machine over the 10-hour period. We're on page 391. So, H equals B minus A over N. I was literally about to say H equals B sine A because law of sines, and then I was like, wait a minute. And the trapezoidal rule is H over 2 times y sub 0 plus 2y sub 1 plus 2y sub 2 plus dot 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 plus 2y sub n minus 1 plus y sub n. So n equals 10. B minus A would be well, it's a span of 10 hours because the first 8 a.m. is is the initial hour. 6 a.m. or 6 p.m. is the final hour. So the difference, we're not doing like 6 minus 8. We're doing like the number of hours. So it would be 10 minus 0, which is the initial hour. So let me do this. B minus A would be 10 minus 0, which is 10. So then H is equal to 10 over 10 because we were told that n equals 10 in the problem. So that means that H is 1. So now with the trapezoidal rule, we plug in T equals 1 over 2 times y sub 0 is 120 plus 2 times 110 plus 2 times 115 plus 2 times 115 plus 2 times 119 plus 2 times 120 plus 2 times 120 plus 2 times 115 plus 2 times 112 plus 2 times 110 plus 121. Now remember, obviously Simpson's rule we found to be typically more accurate, but they've told us explicitly to use trapezoidal rule, so that's why we're using that. To save you from having to type it all in, I will tell you that the answer is 1,156.9. 5 cases. Because I trust y'all can type something that simple in your calculator.
How did we find the B and the A again?
Well, so they told us that it was a 10-hour period. So basically, it's not usually such that your B minus A is equal to your N. This one just happened to be that way. So the 6 p.m. was hour 10. 8 a.m. was hour 0. So 10 minus 0 was 10, which is what gave us that. And then it just divided by 10 because N was 10. You look like you're about to ask a question.
Nope.
Okay. Last one. Which is good because I need to go find Mr. Law and ask him a question.
Well, good luck with that. When you get to
Okay.
Keys law.
Just Hook, but okay. Hooke's law also applies to compressing springs. So that is, it requires a force of Kx
Physics.
to compress a spring a distance x from its natural length. Suppose a 10,000 pound force compressed a spring from its natural length of 12 inches to a length of 11 inches. That is an insane spring. How much work was done in compressing the spring? A, the first half inch, B, the second half inch. So things that we know, there's a 10,000 pound force, which is F.
A lot.
We're going from 12 inches to 11 inches. And we want to know work done. Now, do I know K? Because my formula is F equals Kx. So if I need to find it, then I'm going to take and plug in the stuff that I do know. So 10,000 is the force, equals K times, it was compressed 1 inch, so 1. So that means K equals 10,000. So now we replace in this, it'll be 10,000 times x is going to be our function.
Wait, so are the units for, I guess, spring constant and
There's no units on a spring constant. Physics.
I thought it was newtons per meter.
yeah.
Well, they also don't give us. This one's not going to be in newtons because newtons is only if it's in
Kilogram?
kilogram meters and seconds.
So it's not.
And this one is not because we have pounds.
So right now it's not pounds per inch.
And we're also dealing with inches. Our final answer is going to be inch pounds. For the work done. But as far as right now, no, there's not units. We're just going with. So A is the first half inch. So we integrate from 0 to 0.5 of 10,000 x dx. So what would that integrated be?
5,000 x squared.
Evaluated from 0 to 0.5. So basically a fourth of 5,000. What is that? 1250? So 1,250 inch pounds. That's all for part A. And then part B is just the second half inch. Which is the integral from 0.5 to 1 of 10,000 x dx, which is just 5,000 x squared from 0.5 to 1, which would be 5,000 minus 5,000 minus 1250. There we go. I don't know why. For some reason in my brain, I was not processing that 1250 was a quarter of 5,000. I was thinking it was supposed to be 1225. So then I had to stop and like process it in my head. That's why it was like delayed. I was like,
So you forgot that we found that.
no, I knew we did, but I for some reason thought that was not right. I thought I wrote the wrong number, and I was like, wait. I don't ask. So what is that? 3750 inch pounds.
Still don't like that.
Now, the one I'm giving you is in newtons, in centimeters. But they don't change it to meters in their answer, just so you know.
So we say like Newton centimeters.
The one will just be, part A will just be newtons of that, and then part B is going to be newtons times centimeters. And then one of them that I'm giving you is going to be like the milk problem that we did, but it's like way farther down. But it's still a trapezoidal rule. So problems, just a few with this stuff, because obviously it's pretty much just applying stuff that you already know. 1, 3, 9, 29, and 37.
So, are we done with